Hello, we are live. Welcome to my stream. It's a fairly casual stream, so feel free to say hi if you're joining. I'm gonna give it a couple of minutes for other people to join here if they're so interested, but my intention is to talk a bit about SolidJS, look at a few of the features, design decisions behind Solid, and answer any questions people have during the way. Hey. Oh, while I'm waiting, actually, I might as well talk about some topical stuff. This week in JavaScript's actually been kind of interesting. As you guys know, I spend a decent amount of time on Twitter these days, which is funny because I didn't even join Twitter till 2019 sometime. And hello. And the hot topics this week, there's two of them that just keep on circling, right? I've been talking a lot about MPAs and multi-page apps and streaming and partial hydration performance and whatnot. And sure enough, had a little chat with Evan Yu on there, and the next day, basically, he created a MPA mode for Vue or ViewPress specifically, or ViewPress. I forget which one, which is kind of interesting because it has basically a no JavaScript by default setup. And as I said, it's interesting because it's a hot topic of late, and it's weird for me coming from, because as many of you know, I work on the Marco framework, and we've been doing this sort of approach, same thing as Astro and whatnot, since about 2014. Me personally, not. I just joined Marco a year ago. But it's like this approach is suddenly getting so much attention, and to the point where, as I said, like things that aren't even equivalent, like this MPA mode, are getting it's enough to kind of push people to actually go, oh, I'm gonna make this thing to kind of make a, how should I put it, like a kind of shallow copy enough just to be passable to check mark it, like my framework supports this feature kind of deal. So I don't know, it's kind of interesting development. So that's one. And the other one is this whole conversation. I don't know if people have kind of seen that meme. Actually, I can share my screen for a second here and actually pull that up. I actually wrote about it in my article I released today, but this meme here has been just traveling around like crazy on Twitter, and it's a funny one, because in one sense, like, you got a point, you know what I mean? But on the other hand, you're comparing two very different things. But it's definitely interesting. I think the only part that gets me here is the Svelte example here should have a script tag. It's not actually accurately showing the boilerplate around it, right? Because you actually have to put the Svelte code inside an HTML template in the same way you have to put the JSX inside JavaScript. So at minimum there should be a script tag here, which is probably something that doesn't matter to most people, but I'm just throwing that out there. You know why I make that differentiation? In Marco, you don't need the script tag. So maybe that's a bit of humble brag kind of scenario, or not so humble, but like there are frameworks that allow you to write less code than Svelte. So I don't think it's about that. I think the thing that irks people, or the reason this gets such a reaction, is because it's just a let. Like, let count means something different when you're talking JavaScript, but when you're talking Svelte here, you know what I mean? Like, and I think that's the question, right? But as we know, like Rich Harris and crew did this deliberately, right? They felt that people wouldn't accept a non-JavaScript syntax, and to be fair, it's a lot more work. For their script section, they can use all the tooling you have on standard JavaScript. But it is interesting because, like, I kind of think a reactive language might be kind of cool. Like, we're already seeing reactivity, or at least the language of reactivity, in every single framework. They all have state, they all have some kind of derivation, and they all have some kind of side effect. So, maybe, but something about pretending it's just JavaScript, But it's interesting. Someone actually created Alexis, who's kind of someone who I know from the Solid community, actually went ahead and created a plugin for Solid Babel plugin where you can actually convert um, labels very much like Svelte into solid code. And ta-da, now you still got the function wrappers, but all the imports go away and you can just use labels like Svelte with Solid and JSX. That might be some people's cup of tea. But I definitely like the reason I like React so much in this silly meme is the change that use state to change use local state. Like if you wanted to make this something that went to local storage, from the consumer side, you just change the import, right? You just go, okay, instead of use state, I'm going to use local state. When you make it part of the language, like a label or keyword, you don't get that. So it's a hot topic. I think today there isn't any good answers because all the people who are trying to like do this on the make it still JavaScript side are very much limited by the syntax of JavaScript. Svelte on one side says use stuff like keywords, but then there's no composition unless you like completely change the system, get to stores and whatnot. And then Vue, if you've seen the RFC for the setup scripts or whatnot, which is kind of interesting, they've actually put the they've actually kept the composition by just using a kind of a decorator on the function instead of like labeling the whole line or putting it on the variable. They put it on the function. So I think that's really interesting. But then again, I don't have the example right in front of me here. Maybe I should pull it up. But in order to export it between files, you end up with like a double $ syntax. So it's like it's not all clean. Like there's considerations there to make this work. And I have to ask myself after a certain point, like, are the parentheses you have when you call a function really that bad? I know this isn't a fair comparison to React, but I'm talking about Solid, obviously. Signals mean you have to call a function, but you're just adding 2 extra characters. Like, I don't know. I guess the setter is the other side, and people like that. But I mean, things like Vue already had the setter ability, but I guess you'd have to type .value, so it does get verbose in its own way. So I'm just chatting here to kill a little time before we get into the stuff, but kind of interesting conversations happening all over social media right now about this. And I don't know, I kind of like that Svelte and React are different, right? I think each approach best represents like their philosophy, and I think we should kind of stick to that to a degree, because then you get to explore it. Because like, as everyone knows, like React is big about these kind of immutable top-down patterns, and the whole reason why hooks are the way they are, they didn't want to make them reactive. They wanted to keep that like render everything mentality. When you start, even though you can always add an abstraction to blur the lines, everyone can get their own developer experience, right? Vue's great at that. That's like their big selling point these days. I feel like if you use Vue, you can use Vue that looks like Svelte. You can use Vue that looks like React. Vue does it all. But like these things, which are mostly superficial, like on the surface in terms of like syntax choices and whatnot, as Vue is kind of pointing out, like literally we can compile to whatever, also reflect underlying philosophies and design approaches. And I feel like when React is designing for that immutable system and you try and make it look like Svelte, let's say, you're sort of, even though it'll work, you're opening up the potential for a leaky abstraction, in the sense that people developing work in React are intentionally creating their language that way, right? Like they're basically, this is a purposeful, thought out thing, because it reflects their beliefs and their philosophy, right? I feel like the way it's done in React is expressive enough to be considered better DX. Yeah, I mean, that's sort of, I imagine if you guys feel the same, because otherwise you probably would be using Svelte instead of checking out Solid. But like, Exactly, because when you have that expressiveness, that ability to control things at that level, you can do what you want. A similar thread came up where someone was like, well, let's just use the compiler on the hooks to get rid of the stupid hook rules biting you accidentally. Like, why are we relying on ESLint? And I feel it's because the React core team felt that they weren't comfortable just going all in. And that's something I can relate to. It's funny because I work on a number of frameworks, not a number, I guess just two. I work on Marco and Solid, but it is definitely something that I'm conscious of, right? Because like if you go from, say, Solid to Svelte, there's a couple little tricks you can do, which are hacks, which I'm aware of because I understand the way Svelte works. But untrack is a perfect example, and we talked about this last time in our session on reactivity. If you guys, any of you were able to check it out, I strongly believe that untrack is important. The ability to annotate something that you don't want tracked, and in the same way our components aren't tracked is because, and I don't just automatically put stuff, make destructuring work by like undestructuring it, is because you intentionally don't want things tracked sometimes. This is just a level of control. And I feel like if anyone's used React and had, to fight against those ESLint rules, then just accepting them on base level as a compiler is going to be a problem for you. Like, you're definitely going to have this kind of issue here because more or less, like, as soon as there's any exception to the rule, something that's absolute isn't going to pass. I mean, maybe you can annotate it. Maybe it's a better default. I mean, and in Solid, I do kind of feel that way, right? We, subscribe to everything by default and then untrack the things that aren't might be better than only explicitly tracking things there are. But I mean, I could go both ways on this, it's trade-off between ease, and I actually have gone both ways on this historically. So, I can definitely see that either way. But the one truth is, I personally don't feel comfortable with a language that doesn't have untrack, so to speak, or at least explicit. Like, Vue doesn't like exposing untrack, but they have, like watch effect or something. You can basically, there's a form where you can go only listen to these variables. Svelte does let you do it. It's a little secret. If you put something inside a function, Svelte's compiler can only detect what's directly in the context. So if you hoist something out, suddenly it's not tracked. So there are ways to do untracked in Svelte, kind of, to do it. So, I mean, it's fine too, but if React was to basically auto-detect the dependencies the way Svelte does, you would need a way to do this. I mean, maybe you need to introduce a new explicit syntax, like for mount, because the most common case is if you have something that you only want to run on mount and on cleanup, you're going to pass an empty array to React. And ESLint will complain at you if you do that, because it'll see variables that could be stateful that you could be listening to. And they're like, hey, you passed an empty array, you should have these things in your array. If the compiler did that automatically, well, you'd be tracking it. And in a system like React, where the whole component re-renders, and you guys know, like that whole cycle, this could be a really bad de-optimization to have as a default. Right? The difference in reactive libraries, sure, they are permissive by general, like they always track by default. But the difference is they're also built to memoize everything by default. So so in that case, even if something slips by, it'll get caught by the memo. The value hadn't changed or something, right? But there's a trade-off there. It's not cut and dry, because if you memoize everything, well, guess what? More memory usage. And when you initially try and set all this stuff up, it's going to be more expensive. So your rendering slows down. So a lot of considerations there. Anyways, I probably talked enough about some topical topics. I'm not sure if this is interesting to anyone, but let's get started on the content that I want to go in this stream, which is I want to talk about context, and I wanted to get into async stuff in Solid. And the reason I'm going to start with context here is because essentially that is how Solid is doing everything. And I'm going to use the tutorials here some of you guys probably played with this already, but it just saves me from typing everything again. But I got the playground in case I want to kind of pull out an example or show it, and I might actually end up there eventually anyways. But context API has also caused a decent amount of friction with people because they're like, oh man, why do I have to use this context API with Solid anyways? So there's really two things that I want to cover here. I want to cover like why context, and I want to cover how context, so to speak. So let's kind of start with the first one, which actually I haven't decided which one I want to start with. Let's go with how context first, because I think why is a little bit more interesting. First of all, I guess what context actually, if we really want to get to the start. So I'm just gonna solve this and show it. If you guys have used React before or whatnot, this is actually incredibly familiar. The context API, I broke it up into a separate file here, but you have a provider, passes a value in, and you use that to basically wrap the context. And what's great about this is it's hierarchical, right? If you nested them, it will only see the closest parent that has the context, right? So in our case, we only have one, which is fine, but we basically go through this dance where we define a context object. And this one can actually take the default, that is if there's no provider. This is important to note because sometimes this is really powerful for stuff that you basically expect to always be global, and you know what the configuration is, and maybe you don't want the end user to have to provide a provider. This is a pretty powerful tool, and actually I do use this sort of approach to do some global stuff with Suspense, but in general, you just need this one kind of definition of a context. It's not, other than that default value fallback, it's not really responsible for the value. This is more of like a way of generating a unique symbol so that throughout our tree, we know like it's of the same type. It's like a type generator in a sense. But once we have our context, then we can use it to basically get our provider, which almost always looks the same. It's a matter of passing a value to it and the children, and then ability to use that context. And it's very common to basically wrap both parts, right? Wrap the provider so that the end user doesn't have to deal with the dot provider, and you can maybe put specific logic in here. Sometimes you do leave, more kind of settings to the end user. In this case, I just take a default count, but sometimes they pass like much more data into this, but this wrapper pattern encapsulates it pretty nicely. Obviously, this is a bit of boilerplate, but once you do that, and if you wrap this, they don't even have to import the context. You basically just end up with this pair, provider and consumer, more or less. And then from there, you can just use this consumer anywhere. Let's see, I got a couple of comments already come in here. What do we got here? Don't people just bump into the need for context when they're passing a bunch of junk down the tree manually? Yeah. Yeah. I mean, that is the most natural place it happens, because I guess the best way I can put it is, if you start building something really simple and it's not just about prop drilling. I mean, that's where the kind of more localized version and the more powerful use of context. But usually what ends up happening is you start building something and it's a component. Then you start realizing like, oh, this is way more than I thought. So you start breaking it up into more components, and you start, needing to pass these props around. At a certain point, when you build something, and this is true of even like bigger apps, it's not just like a stuff that's related necessarily. You start realizing that in order to, like, if it's suddenly a new part of your app that's not in that direct tree needs to use part of your state or share state, like maybe you need it now in the sidebar. Like you basically had this data that you loaded about the main user, and you had it in your main window of your app, and then you're like, oh, later new requirement, new build thing, you need it in the sidebar. Suddenly you don't have very many options to share that data. The way we tend to do it is we just hoist it up. What I mean by that is we actually lift it up to a shared parent. And while that, seems okay at first, maybe, but depending how big the app is, and you've gone that far, that shared parent could be so many levels removed that, how many components can you pass it through? So yes, it is about the need to, avoid prop drilling and passing state through components that don't need it. But sometimes it actually naturally happens the opposite way. Like you had something that you only needed locally, and then, and even if you pass through a couple components, you're like, whatever, but then suddenly you need it somewhere else, and suddenly it goes all the way up the tree. And then eventually you're like, oh, I actually have to wrap I needed my whole app. And at that point, putting the state, that high up the tree might be really awkward to pass it around. So I feel like that's the origin of it. But all that being said, and I'll explain how this works. Actually, maybe let's just continue, and I'll explain a bit more how this works in Solid to kind of get an idea of how the way we approach it might be considered a little bit different than React, and has different considerations. So in this case, this is like such a naive approach, because all I did here in this simple demo is I have a main that has a nested, and notice how we did not pass the count stuff into nested or into app. So basically context lives out here outside of app. App basically doesn't use it, doesn't care. And then nested uses it. And this way we cleanly get that our counter into, it counts up, it counts down, into nested, into our counter component without app having to worry about it. That's sort of the what that I was talking about. What's interesting from a mechanical side is how do you implement this? And I'm going to talk to it a bit more than actually showing the code, but when I approached this problem, I had a couple options. Those options were like, I came from kind of an interesting background. I don't know if everyone realizes, I actually spent an incredible amount of time on web components, which is probably surprising to people considering how many, well, I would say like how maybe anti-web components some of my sentiments sound, but I spent a good 7 years using web components in production. And when I approached context, remember we have no virtual DOM in Solid. I was like, well, with web components, we would just use the DOM tree, because like you have to remember, one of the key differences with Solid, and you might have seen this before with our fine-grained reactivity, is like if something updates, and I'm just using context here in this example, like this count updates only, and I've shown this off a few times, go in the compiled output here, but where is our counter nested component? Like only this, like this insert reruns. This is basically a create effect, and it's only this count thing that sets the text in here that runs again. So like if it's some arbitrarily nested level, something reruns, I don't have access to a full virtual tree or something. Like how do I possibly walk up to figure out what the context is? This is something that I was really struggling with when I was first approaching context in Solid. So it's like with the reactive system, any piece can just execute whenever it feels like, completely independent of any kind of like top-down renderer. So the first thought was like, well, if I have the DOM elements, I have the whole DOM tree, then by the time I get down to this component somewhere, I could like maybe know a DOM element and then kind of walk up the tree until I can find a DOM element that I wrote the context to. And maybe that's where I can find like the nearest DOM element in the tree that holds some kind of context, and just make a mechanism that writes it to the DOM. This seemed like it'd be fine. And that's essentially what web components can do, right? They can like send up a DOM event or something, and then basically an element can basically listen for it and go, yeah, I know how to serve this. Essentially use the DOM tree. The problem with that though, for us, was initial render. If you look at Solid in terms of, actually this nested component's probably, no, this one's not a great example. Let's actually just go to the playground. Let's look at our simple button here. If you look at what RGXX is executing here when we render, we clone a node, we add some stuff, click, hook up this account, and then we return the element. At the point that we return the element, like that we're rendering, up to this point, this DOM element is not connected to the DOM. And that's actually really awkward here, because let's say I needed to use the context here, like in our last example. When I get to the counter and I'm initializing it, the DOM doesn't even exist yet for it. And even though the parent DOM might exist, our component isn't really aware of it. We haven't attached ourselves to it. There's no propagation, there's no trees. And that's a whole difference. With web components, you end up doing most of your work in what's called the connected callback. And the reason for that is web components have, I'd say, 3 major life cycles. They have the constructor, which is create, and then they have connected and disconnected. And the reason that a lot of work happens on the connected one is because there's no destroy. I mean, that's changing now with weak refs or whatnot in the finalization registry. But I mean, I'm talking years ago. You essentially needed to use connected because disconnected would have been the opposite, the way you do the cleanup. You connected, create, disconnected thing. So it's fine. You actually have the DOM at that point. But for us, we don't have the DOM, and we could do the DOM, but the DOM's kind of inefficient. I'd rather virtually create everything, figure out what I'm doing first before having to deal with a bunch of DOM elements. Making a component into a DOM element seems a very expensive price to pay, when it doesn't need to be one, right? Like something where we have more elements we have to worry about. We have to, it just was not where I wanted to go here. Let's see, I got a few more questions coming in. Yeah, let's see here. Rather than use context, could you use primitives directly in a module and import them whenever you're needed? Yes and no, and I'll get back to that in a moment when I talk about the why. So let me get back to that in a minute. But what I'm getting at here is using the DOM is a no-go, because we basically, like, if we put a child component in here too, like let's go back to our other example here, and where we create the nested component, which is in our app here. Sorry, the code's a little bit, but what I want to show is even in our app component, it's so small I didn't even notice it. It's funny because the app here looks like this, but it ends up just becoming an array that creates the H1 and creates a component. Even if the way JSX executes, and it's true the way even Solid executes generally, is it actually executes sort of inside out. Like you create the children before the parents are done. So like in this example, it's because like if you have a function that calls a function that calls a function, and you're passing, you kind of compress up, right? You can't call the parent function until you've called the children that you're going to pass to the parent, right? And in that sense, because the children are getting created before the parent, this even more exemplifies my point here, that there's no way to use the DOM here, and you wouldn't want to. So no virtual DOM and no DOM. Context was actually it was like the first challenge that I had to solve with Solid in terms of like figuring out what I was going to do here. And I guess without the why, you're like, why am I worrying so much about context? I will get there. But this is the new ground. No other fine-grained solution that I'd come across that actually had a dependency detection system like this without a virtual DOM, or without like web components, the real DOM. So luckily, I had a solution. And as I said, I'm not going to show the code for this right away, but we, in Solid, for memory reasons, and this is I covered in the last video, I'm not going to get too deep, we have this concept of something called create root. And it's basically just an inert create effect. And the reason for it is everything in Solid needs to be in a in a reactive context, not the signals, they don't really matter, but any kind of computation, because they register with each other, and that way we can handle disposal. Like if you nest them, you would have to manually handle it. And this is something I used to do with Knockout sometimes and MobX back in the day. But with Solid, the disposal happens automatically. We actually register any child effect with its parent effect, so that when the parent reruns, we can free up the child and then continue on our way. And the reason for that is if a parent ever reruns, you're going to be recreating it anyways. You do rerun that whole function. There's no ways around it. So if you didn't, you would just keep on adding the subscribers on and on and on and on, especially if the signal lives outside. Like, as I mentioned, this counts a create effect. If for some reason we had, well, let's just do it. Let's just do it. Let's cover this with a show component here, right? And show when count module 2. So good. All right. TypeScript, my favorite. Okay, cool. So let's do it the other way, because I need. Oh, actually, this isn't going to work because the button will disappear. It's so funny. This catches me up in every live demo I ever do, because I'm trying to show something with show, and this basic example always has the button doing it, which is really short and simple, but obviously doesn't lend well to me hiding and showing stuff. But let's just put the count on the inside and make this, click, whatever, right? C1, disappear, 3. Basically, I'm only showing it when it's odd, right? And yeah, I mean, honestly, this is a little overkill for a show component, right? We could also just, if I knew I was just gonna do this, I would probably have just done something much simpler, something like this. But whatever. What are we doing? What am I doing wrong here? Is it because this actually is a? Let's try this. Oh, it's because I'm dealing with numbers here. This is like, see, JavaScript. Show saves you from JavaScript. But yeah, you get what I'm saying. If every time it counts, we're actually tearing down this context, tearing this down, and in this effect inside here. This, as you can see here, we actually compile this to a couple memos. I'm actually let's make this a div. I know it probably should be a fragment, but this will just make our code a little simpler to see, because the way the cloning works. But my point is, we actually, inside our insert, we actually end up hoisting this expression into a memo and then return that. There's a bit of IFEs doing here, like self-executing functions. Don't worry about that too much. But my point is, this this is how we protect from over-rendering, by the way, on conditionals. But this kind of sub execution, every time it actually would go, we'd be recreating that memo. And actually, we don't recreate the memo, actually, sorry, because the way that IFE works, it actually calls the outer memo. Anyways, that's beside the point. What I mean is, we're recreating a subscription, right? Because it needs to subscribe to count anew every time. If this subscription that happens here needs to subscribe every time it's visible. When it's, I guess it has the outer subscription. God, this is just a terrible example. I'm sorry. But my point is, you would be just, if you didn't have the cleanup step, you would just be adding more and more subscriptions to the signal, because the signal never goes away. It outlives the computation down here. And for that reason, we need to clean up. If we didn't clean up, the signal would just get more and more. And even if the stuff wasn't on the screen, you would still be subscribing to the signal up here. if that makes any sense. Oh, some people are noticing stream problems. Okay, I haven't seen any warning yet, but hopefully they have subsided. But essentially, it's very important that we clean up, and so that's one half of why we have create root. It handles this cleanup for us automatically. The other reason we have create root is because it helps us schedule effects like things after render. If you want, it's a reason that refs work in a mount or in a create effect. It's because we can actually do all the pure computational work, then do all the rendering, and then run your effects synchronously. Some frameworks use micro tasks, which then go, okay, we'll queue it up, and then when it's all done, we will run the micro task, and then it knows it's done. But micro tasks aren't necessarily free. So we actually go for synchronicity to ensure glitch freeness, and for this reason, to have something run later synchronously without queue, like we need to be able to wrap the whole expression, so to speak, so that we go, okay, it's all run, now run this, right? We need to be able to control that execution. So create root gives us that, and render just hides the create root. That's why we pass a function. If we just pass counter, it would run before render ran, and that's no good. We actually need it to be under our context, so we pass a function. So basically, we can pass this function to create root, which is, as I said, it's just an effect that doesn't track. So a little long-winded explanation, but my point is everything core under solid is under an effect, essentially to handle both automatic disposal. As I said, signals don't need disposal, but all the expressions do, like all the computations, create memo, create effect, and to handle scheduling. So context was actually kind of nice because it was a way that people were already used to using these patterns, and it sticks it under the tree. You don't have to worry about disposal or scheduling or making these wrappers yourself. I mean, context is a wrapper, but it's basically built, like people are used to using that pattern already. So I was just like, win-win. But the biggest difference, right? If you use React, people kind of tell you, don't use context all the time. Like, don't overuse it, right? I don't know how familiar you guys are with that, but at one point, Redux, I think it was Redux version 6, actually used the context API to do their stuff. Like context was already kind of like this hidden thing that everyone was using. There's the legacy context, and the legacy context wasn't very special. It was kind of like a hidden object kind of behind the scenes that you could access and leverage. But with the new context API, suddenly people were using it like in components and using component standings. Redux is like, we can simplify our code greatly. We can get rid of our subscription system and that whole thing by simply just using state like context, and we're happy, we're good to go. Well, not exactly, because when you use React and you have context example, like our lovely example in here, and let's say that state in our provider, I showed you our counter provider. See, we created a single signal. If this was React and you're creating state here, it would belong to this component. So effectively, by setting this count, or in our increment or decrement functions in React, you're actually telling the counter provider to rerun. So in that case, going back to our main app, the topmost component of your app reruns. So the default behavior in React means re-render the whole tree, like literally everything. Obviously, it's not re-rendering the DOM, so it's like not like super expensive. But as a default, people who just use context kind of naively for global store means like, there goes the whole app. People did it because it was kind of like, oh, we got this new tool. But if you're doing regular updates, obviously changing a theme or something, like not a big deal. But like if you have regular updates, that's kind of detrimental to re-render the whole virtual DOM for the whole app. Obviously, there's like memo, right? There's a, what do you call it? The React memo can stop some children and stuff. But like it's not that clear cut because some things do need it, and the descendants need that change. And if you actually want it to propagate, you actually have to let it propagate. So that's why context doesn't replace Redux. It's so funny. Mark Eric's and like the maintainer has been fighting this for a year. Like it feels like the last 2 years is like every day he has to like correct something and be like, no, it's not the same thing. Doesn't replace it. And he couldn't be more right. But it's hard to fight a trend, especially on social and like we're out there when people have like already, figured it out for themselves, the truth, even when it's not true. But my point is in Solid, as you guys know, this signal is not owned by this provider. It doesn't care. So you're literally just passing the signal through. So by the time it gets to nested, it's just like this one subscription that runs, right? We don't actually need to rerun the app with our context API. So for me, this felt like really good because I was thinking, hey, I don't need to explain create root to anyone. And so they can just use this pattern that any React developer or Angular, like it's not unlike Angular's dependency injection, or Vue actually has a version 2. Basically, every framework accepts, well, even Svelte has their stores, but not their stores, but they have a context API, but it's like not quite the same. But like they all have this means of doing this. So it was like, sweet, everyone's familiar with this pattern. I don't need to teach people create root. And in Solid, there's no downside. This is as good as if you just imported it, like put a signal out in space and imported it. So that's a bit of the why. I thought I could actually simplify things for people. Let me see. Someone had an interesting comment. Let me read this. It's an interesting argument in React about whether context is simply dependency injection to be used sparingly, or the whole state managed tool that can replace Redux. Yeah, that's exactly what I was kind of getting at a couple minutes ago, which is probably when you actually made that comment. I think it's a wrong comparison. Like it's just not the right way to be thinking about this. There is some hope there. React's talking about creating kind of a built-in selector API so you can kind of use context efficiently. But you know what? Like maybe the fact that this doesn't work out of the box is kind of an awkward slide against React. It's probably part of the reason many of you guys like Solid. Like it's context kind of a great mechanism and makes a lot of sense, but then, oh wait, you can't use it for this scenario. That's a weird conflict to have. You introduce hooks, you introduce state management, and then like, oh, but don't, right? Yeah. Completely. Yeah, exactly. Like the expensive part is walking up the reactive tree. I explained that I didn't get there. Sorry, I kind of got sidetracked. But the context in Solid, if I didn't explain it properly, was actually really easy to do because each child registers with its parent, right? So that it can be cleaned up. I just piggybacked on that. So each child knows about its parent. It's going to get cleaned up anyway, so I don't have to worry about it leaking. And so when we get to context and we're like, oh, get me that context value, when whatever scope, reactive scope is running, we know what it is. And then we go, oh, we just backlink up the parent. We just walk. We just go, oh, does the parent have this context? Does its parent have this context? This parent has context. So it isn't, that walk is a linked list. It's not expensive. And it isn't even per component. It's actually per reactive context, like which is based on like dynamicism, like conditional branches or for loops and stuff. So even in a giant app, you might walk up giant, you might walk up like 15 to get to like the top level global one tops. But like, how long does it take to traverse a 15 item link list? That's your overhead. It's not expensive. It doesn't mean any re-rendering. You just have to literally go next. It's nothing. So yeah, I'm sorry I didn't actually explain it, but that's what I'm talking about. Create root and create effect. You already have the means. This is the tree that's already there for us. So I had my solution. And it's funny enough, no other reactive library had really taken that approach. Yes. Okay. The provider hell. Yes. That is fair. Um, yeah, and I will grant you that. I have thoughts on the provider hell, to be fair, and I mean, the first thought on the provider hell is like if you're using something like Redux or whatever, and you make a single global store, then you don't have that much. Maybe even if you have 3 or 4, like as long as you're not like making one for each thing, maybe you're fine. The other thought on the provider hell is, and this is more radical, and I'm not going to suggest we can get there right away, but maybe global stores are the wrong pattern. I'm very into stuff like React Query. Um, um, you know what I mean? Like it's possible that we can pull out global caches and then not have to worry so much about like kind of write our code as if it's local. That's my hope. But I mean, to be fair, there are other patterns to bury context. You can use patterns like the stand type patterns. I can show that in a minute. Um, so we'll get there. Um, Thank you. Yeah, I mean that was the goal. It's kind of funny how that just kind of happens. I wasn't like trying. I'm when I start I when I was starting when I was starting working with Solid, I wasn't like, oh, I'm gonna make a React clone, which people might think because of where we ended up. I was actually like I wasn't even on JSX initially, but then JSX made a lot of sense, and then I was like I had my stuff, but I was like, I didn't like the two-way binding, and I didn't want the syntax, and I was like awkward. And then I was like, okay, I could do explicit. I always use knockout, and I was trying to figure out a way to break the rights and the sets together. And I was like, okay, I can do like MobX box observables. You can use get set, maybe that'll work. And I wanted to kind of get away from those patterns, and I made my proxies read only, like the stores. I thought that was the main primitive because I thought no one would accept signals. And I was kind of happy with that separation, but basically I just have a set method top level on the store object. And it wasn't until React hooks I was like, oh, like why didn't I think of that? But then when I changed to use that kind of setup, people, like it started getting really looking like React, because like, okay, now we have hooks. It's funny, React didn't have hooks when I was working on this, but now we have hooks that look just like React hooks. We're using JSX. Like context was a good pattern. I just like a lot of stuff React did, and it just, it ended up that way. What do we got here? Yeah, and you only have to walk the tree once. Yes. And do you know why? Do you know why you only have to walk the tree once? Because your component only executes once, right? It's the same thing, right? You just needed to get the reference in the first place. So it doesn't have to happen every update. Okay. Cool. Yeah. And I've been looking at it. I actually made like an SWR thing in one of my things I was playing with, but I have a few cross purposes to consider here. I think I want to handle caching to do with suspense and stuff first, and navigation and routing, before I actually figure out what the right pattern is there. So that's why I said it's a little premature for me to just say like this is the way, but I sort of picture this. I mean, if anyone's seen the remix demo, the remix run beta demo, that was something. I remember when I first saw it, and I was like, man, these guys beat me to it, a little bit, because I mean, it's not surprising. It's the guys who created React Router, and React Router is based on Ember Router, and my first web component router was based on Ember Router. Basically, Ember Router just changed the game when it came to routing solutions, in terms of having nested routes as a concept for front end. Like this, you don't have that same kind of concept in the back end. It just doesn't make sense. The idea that you could swap out portions of the page and do layouts, and that it's actually kind of essential in reactive library, because you couldn't do diffing. So that's why like older libraries like Ember had this approach, because they were trying to avoid diffing, so that they had nested routes. And React Router 1 had it. And then at a certain point, they just got rid of that approach and then went to like the React Router 3, 4 that everyone's familiar with. But then they brought it back in React Router 6, basically to make Remix. And I knew Solid, because the way we render, had to have a nested router. So I was already working on that, and I was looking at React Query, and I was like, okay, well, how do we put these things together so that we can refresh on the route change and know we from the route and data, we can parallelize fetching, we can get rid of the waterfalls, we can, a lot of benefits here. And then, as I said, I saw the Remix run demo, and I was like, okay, yeah, okay. So that's the last little bit I needed to jump over. So yeah, do expect that the solutions for Solid the starter package, kind of like Next.js felt kit kind of approach Remix thing is going to be very similar to Remix Run in that sense, because that I needed that approach to actually, that's the approach you have to take with fine grained reactivity. So it just makes sense. Anyway, kind of got off topic, a bit long-winded, but that's great. Keep the questions coming. Let's see here. So getting back to where it is, I basically revealed the big power of context here, and I talked a bit about the what, the how, and the why. But you guys are already doing, see, I got you covered without context, right? How can we do this without context? I have this example, and some of you are probably wondering, why this create root business? Create root. Truthfully, you can put a signal anywhere, import it, and it works great. Someone's already commented on that. Go for it. If it makes sense for you, whatever. But the thing is, sometimes you need to derive values. Sometimes there's resources, which we'll get to when we talk about async. Sometimes there's different types of computations, side effects, all these kind of things that you want in here. And suddenly your global store just stops working. And you're like, what the hell is wrong here? And it's because you didn't follow the tutorial here. But it's because the create root is really fundamental. I said both for the garbage collection aspect and for the scheduling thing. As I said, you could just do the Svelte store thing, export a signal. And I sometimes do that as kind of an example, because when people go, oh, look at Svelte stores, I'm like, I don't get what the big deal is. Like, you can do this in Vue too. You can just create a ref and just export. Like, every reactive library has a reactive atom. So and the funny thing is, any reactive library that has a reactive atom that can be used as a store, like MobX's box observable, Vue's ref, Solid's signal, they don't think that's a suitable store. I don't know why Svelte decided that was a suitable store. I mean, it's fine, but it's also oversimplified. Like, there's a reason Redux has selectors and all that complicated boilerplate around choosing what little things get updated. It's because you need granularity. You don't want to update the store and then just update everything, right? So if you're simple, it's fine if your store holds a single value. Great, you got a signal like our count. But now let's hold a list of users. If one user updates, do you want to trigger everything that listens to any user? No. And if you have a single reactive atom, you need to do stuff yourself. I mean, we can do is take the atom and then add selectors to it, use those type of patterns. But I honestly, I don't question stuff on the Svelte side. It's just not worth arguing with people around. Arguing to people about this, I think, on social media, because I think there's a real desire to have a simple approach. But as I said, any library that's been doing reactivity 5+ years knows that that's not sufficient. So I mean, maybe it is. Here's the thing: you know how you can use context and re-render the whole React tree. You can use a single atom and re-render everything. And if your framework's faster, like Svelte is, maybe you don't notice. Maybe it's not a performance bottleneck. There you go, simple. But I don't see how that scales to real things. And I'm fairly certain that as, Svelte gets more adoption, which it will, and it should, because it's brilliant, people will kind of go, oh yeah, I need to do a bit more. And then eventually we'll just get to a point where people, generally realize that all these frameworks have the same problems, you know, and you need solutions for them. And, you know, there's two ways of thinking about it, progressive and non-progressive. Vue kind of introduced this idea that learn only what you need, feel comfortable, and then kind of level up. Svelte kind of taken on that role too, you know, just simple, got some HTML, some script tag, here's a let variable, let's do what we need to, and then if it ever becomes a problem, level it up. This is an exact contrast to React, which is like, look, here's these, you know, 6 things. Like we have a few more. There might be 18 things, so number more. But just look at these 6. Know that there's the other 18. With these tools, you have everything you'll ever need to do anything. And that's the same approach I take with Solid. I just like being upfront. Like I think there's value in just being like, look, this is how it works. Your perception of how it works never needs to change. That's the difference. I don't think it's easy simplicity. Like everything's the same to a certain degree, like from a high level version. Nothing is actually simpler. So anything that sells you on easiness is lying, like so to speak, right? Like you'll need to learn it eventually. So yeah, you know, to each their own, so to speak. But my point I'm getting at is, when you need tools to do it, I want to provide the primitives that allow you to build towards that and know you can build towards that right off the beginning. So yeah, you don't need, you know, I mean, you don't need to have, you know, context. And actually, you know what? Let's do a little exercise here. I think you guys might appreciate this a bit. What if instead of like, yeah, maybe I'll just make another file. Let's see if I can make another file here. I'm gonna call it store just for the lack of a better word. Don't hold me to it. But what if we did something like this? What if we let's make a new create store, right? And let's make that store take a function, okay? And let's make it do something really simple, which is create root, and inside that root, actually, you know what? I mean, this is almost a silly abstraction because you could just use create root and not even worry about it. My whole point is, like, now let's go through the exercise. Let's just do this. And then let's have it return create root, and then let's have it go like this. So weird that it looks like when you open a new tab, it doesn't have the proper tab alignment. I'm a big fan of like 2 spaces. Apparently this just defaults to 4, which is visually bugging me, but whatever. Okay, const store equals execute our function, and then let's return a function that returns the store. I mean, it seems kind of a little bit silly here, but the reason I want to do this is now let's change this around. Let's make this. I need a couple more things here. Obviously, I need to import this in here. But my for anyone who doesn't want to use context, what if we just thought of things like this? What if we just, instead of doing this, let's go import create, or it's default, made it default, didn't I? Yeah. Import create store from store, right? So now we get here, and then I'm just gonna inline the whole thing because it just makes it feel more friendly. Like create store or export default create store and this. All right. I was a little hasty removing the solid import. Someone probably pointed that out in the chat. I haven't checked yet, but you know. My point is, I've abstracted away this create store thing with the create root, and I had it return a function for a reason because you know, um, you know, I mean, it doesn't really matter. I did this just as an object, but it doesn't matter. But now, like, how's this for a pattern? All right. Now the question is, what did I do wrong? Right? Semicolon missing somewhere. Thank you. This is. Uh, this is why I use the playground instead of the tutorials to do this stuff more often. What am I missing? Oh, yeah, function, right? Yeah, so our store works, right? So basically, if we wrap a create root and have it return a function, um, and now what you can do is you can just create a store somewhere, pass it a function, set it up however you want, and then import this file in your file and use it. So like I just very simply made a different pattern that uh, doesn't use context, but it kind of safely creates a global store. Because the thing is, yeah, sure, the disposal doesn't. I'm assuming because it's global, you never need to dispose of it. Maybe that's a wrong assumption, but because it's global singleton, we're not going to worry about disposal. At least now, like effects and stuff won't have issues or resources, and you will basically use a fairly familiar looking pattern. Let me catch up on some comments that have come in the last couple minutes. Yeah, this is a great observation. And yeah, why not? I mean, to be fair, I've been keeping stuff out of the core because I want to keep it slim. I want to keep it, you know, I wanted to keep it slim, but to be fair, we actually have some libraries like almost like use React. There's a solid primitives library that David, one of the core team members, has been working on for a while, and I feel like stuff like this just belongs there. We'll get good recipes, and maybe someone will make it back to core, but then for now, let's just kind of play with things and see where it goes. Yeah, there's so many positive comments here. Yeah, yeah. Share a few of them. Yeah, no, I mean that's the thinking. Yeah. So if you did this without create root, what could go wrong? You explained it. Basically, if you ever use create effect, it will not work. That's the first thing. It won't be scheduled. Other than that, the only thing you have to deal with is a compiler whining at you during dev mode, because I purposely warn about creating stuff outside of roots. And the reason I do that is because sometimes people go promise then create something, or they put in an event handler, and that creates memory leaks, like I said at the beginning. And those memory leaks are kind of terrible because every time you get unexpected behavior sometimes, like phantom updates, like it's just not good. I Rather than explain it to people, I'd rather just make a simple primitive that works in every case. That's where my mentality comes from. If you only use signals, there's no problem. Even if you use memos or my create computed, it will complain at you, but there's really no problem because there's no expectation that this gets released. But it's but it will complain at you in dev mode. Yeah, and I think yeah, it's kind of like the super batch. I need something to start the batch, start the transaction, start the whole thing running. Yeah. That's kind of the idea here. And the reason I spent so much time on context, and we'll see how far we get on their stream today, but is because I want to kind of lend this to where the next set of topics here. We're actually about an hour 5, so we're about like halfway through. What I was intending. I tried to stream for a couple hours, but we'll see how it goes. But essentially, why is context relevant to everything? It's because I actually use context for a lot of things. I use context is how we do error boundaries. Context is how we do suspense. This is very different than React, because Solid is very different than React. But I'm going to start with what I consider the simplest thing. I'm going to move into async mode unless anyone has any more questions about context right now. Here's your shot to ask me about stores or context. I mean, not stores. I don't want to get too much into the proxies, but patterns around global storage. There is a difference between what's in the store and the context, which again is something that Redux maintainer has been trying to explain to people, that context isn't replaced for Redux. Maybe use reducer could be a state management using Redux, but context itself is just a container. Any more questions on the container? If not, I'm just gonna move on. Okay, yeah. Let's get back into our playground here. Maybe I'll just start a new fresh one. It's funny. I just keep this counter gets way too much work, right? We'll worry about that in a second. What I'm going to do is show you something kind of really simple. Because for me, when I talk, I had this in the tutorial guide section before, but I wanted to kind of show you the mentality difference here between React's re-render and Solid's, because just do a bit of div soup here. So this is what granularity buys you, and let me show you what I mean by that. Is I'm going to show when count, and count is 0, so I'm not showing it. But let's do something here. Let's go set timeout, and let's give it a little bit of time. Actually, so we can see it, let's add a fallback here. Just let string, why not? So loading for 2 seconds, high, right? And basically, we've all kind of seen these loading state scenarios, but this is why, even more than other frameworks, when I first, was working on Solid, I was like, maybe I don't need these things that like a VDOM library has. Like, it's in Solid, when you do this conditional thing where you do the show component and you do the loading, and then if you look, the children are lazy. So until it's true, we don't clone and create the div, and when we have this, we got our fallback. This is static string in our case, so it just inserts it as needed. But my point is, in the same granular way that we've been talking about, and this whole thing's an insert, right? Keep in mind. So you create a component. This show returns a memo, more or less, if you want to know its internals. So it basically returns a memo that returns loading until it flips, and then returns clone node and creates those nodes when it flips. And my point is, when we go from 0 to 1, we don't re-render anything. All that happens is count triggers the memo, which clones the new nodes, which then the effect that was listening, the insert, goes, oh, I've updated, and then inserts it. So it doesn't involve two computations running. But my point is, we don't re-render the rest of the tree. We don't do a bunch of extra diffing. The only diffing that happens is we go, oh, replace this text node with our new div element. That's the level of diffing. It goes, and it's actually really simple because it goes, in this case, there's only a single element. So it goes, okay, I've got a DOM node. Is my current value any like thing? And in this case, it'll be a text node. And I'll go, okay, well, I'm swapping one node for the other node. Like the diffing isn't even like diffing. It's like just replace. And we don't re-render anything. So if you pictured that this is some kind of like async waterfall, like you're rendering your page in React or VDOM library, or even in like Svelte or like any kind of any kind of component-based thing, you have to rerun the component essentially when that piece updates, right? And it's more pronounced in a VDOM where you have like the children and all that kind of consideration. Each component is an island, or island's a wrong term, because you guys will think partial hydration. I mean, it's like its own thing. Like in a reactive component library like MobX or whatever, or Svelte, you have this automatic memoization at the component boundaries. So like if it's just that changes, only that component runs. But my point is that this pause and continue with Solid is almost free. Like we don't have to re-render anything in order to continue from a pause, right? We just go, okay, render what we can. So, render this div. Maybe if there's another element after it, render it too. You just continue, yeah, I mean, always here, I don't, we don't need to do anything here, right? So we don't have to render some virtual nodes, or our cost of async continuation is almost nothing. And that's sort of like what I'm getting to here is, I didn't think I needed Suspense. I didn't think I needed anything special for async. You just instead of set timeout, make this a promise then, like it will just pick up where it left off. But that's actually not the benefit of Suspense. See, the benefit of Suspense is actually in twofold. And if you guys haven't seen it closely, it might not be as obvious, but I'm not going to get into, we'll see if we get into concurrent stuff and transitions and time slicing. We can ignore that for a moment. The benefit of Suspense is simply inversion of control. Old design pattern thinking. It's that in this case, our loading state and stuff is above. So, our parent, our counter, whatever, holds all the cards. It knows the state and it knows how to show the loading state. What if you want to kind of depict that maybe from a navigation standpoint, like at a page level, and you don't want to know? And I don't necessarily, there's two sides of this. Like the most obvious one is, if you pretend you want to show a loading state for each page when you route between it, or tab or whatever, you can basically do with Suspense. You can do that without knowing what the tab is loading. So that loading could be something that happens below, or it could be something that happens above. Maybe you're using context. It doesn't really matter. And the reason it doesn't matter is because of the way that Suspense works. And I'm going to get into that a little bit, but essentially, the first example that everyone sees on async and Suspense type stuff is this example of the lazy component. This is the most obvious way of seeing what I'm talking about, that inversion, because our app component here, once I add the Suspense, and it's so fast you don't even see the loading. Like, can I? Not even, right? It's because, but my point is, this is actually funny because there's no Suspense in this example, which is why there's actually no loading state. I was trying to just show that the welcome would show before the hijack, but it's like way too fast. But my point is that essentially right now we don't have Suspense, but if we actually had something with Suspense, something higher up could make that decision. So like right now, you know what, let's make this actually work, do some work. Luckily for me, I actually included an example here where I kind of trick lazy to being slow. So now we see that there's a second, right? Without Suspense, this greeting, the way lazy works, it just doesn't return the component until it's ready and then passes the props for that new component. But without Suspense, you can clearly see welcome, and then it continues. This is not unlike that example. That's why I showed you that example a minute ago. This lazy component is just a fancy way of doing this, essentially. We're just showing it when it comes in. But when you add Suspense, I mean, you could choose where to show the placeholder, right? This is sort of individual control. Like, if the thing isn't lazy, then we never have to actually worry about any of this. So let's import Suspense from SolidJS. Loading again, why not? Loading, hijack, right? Like, essentially, but like, I mean, I don't know why you do this necessarily, but if you didn't want to show the welcome until it loaded, you could do that too. You arbitrarily just pick where that point is, and it doesn't even have to be the same component. And greeting, if greeting is not async, then, you know, if there's no extra cost here, if greeting is just import greeting from greeting, well, then no harm, no foul. Like, that's the beautiful thing about it. It's basically a way of hoisting or delegating control over those states without the parent needing to know. And as I said, in this case, lazy is a really good kind of version of this, because essentially that promise, that request, is something that's happening nested somewhere down the tree. You don't know which components are lazy. Don't worry about it. Just show a consistent state. Because the thing is, if each separate component needed to handle a state, you might end up with what they call spinner hell, or like a whole bunch of different spinners. Sometimes you're like, you know what? This whole section of the page should load together. I'm just going to wrap it in Suspense boundary, and I don't have to handle the individual states. Yeah, let's see. I got a few comments coming in here. Yeah. Yep, exactly. It shows, you know, you can make an auth component out of show pretty easily, and kind of handle the timing that way. Sorry, it jumped on me. Yeah, exactly. That's the main principle behind Suspense. It's basically this nice wrapper. And that's the thing. For Solid, the dynamic loading would happen anyway, because it's not any different than my show component. We just continue where we left off, right? Like, there is no need to throw promises and re-render stuff and like it, it, like don't get me wrong, there's a side effect to this because I say there's no need, but it's a deliberate choice. And when I say deliberate choice, it's because in Solid, I don't want to re-render everything. So from a cost perspective, I have no need to re-render everything because I can just pause and start instantly, right? But on the other hand, I don't want to re-render thing. If I threw the promise all the way up and then we would have to re-render or continue, there's no continuation, right? We don't have that in the language. Maybe generators are the best option, but then I don't want to like make the whole renderer or generator aware or whatever. So um, like throwing promise would never work for us. So uh, I needed to use a different mechanism to be able to continue. And the thing is, Solid's already so good at continuing. So why throw, right? The problem and the trade-off here is, if this is something that depended on some real data, which we'll get to in the next example here, then that data might be null, right? Like if you look at my example here and pretend like I'm just using count to flicker it, but pretend that like I wrapped it in a show because I'm kind of showing like our naive suspense approach here. We're showing the loading state, but essentially, if you don't wrap it in a show, if you're not checking if it's there with Solid's approach, it won't just work. See, with React, the second you hit an error, with the second you hit something that's not there, it's going to throw the promise. So suspense saves you worrying about like these null states. So, and a lot of people think that's the point of suspense, and it's I guess it's a nice benefit, but that was something that was. It also means a lot of rework. Solid's already so good at continuing, and with React, the first promise you hit that suspense, you have to stop rendering. You got here, you stopped. You know, um, which might be good. So you stop here and you don't render this always here thing. You just stopped. But the difference is with Solid, you do render the always here, and when you're done, you don't need to re-render the always here. It's already there. And I think that's better because let's face it, you're waiting. If you're waiting for something to come in, do you want to do more work while you're waiting, or do you want to push off that work for when everything comes in? Like it's more performant even and better scheduling in a sense to actually do the work ahead of time. So stopping on the first interruption actually is like a de-optimization in my books. So yeah, it lets the child components choose when the suspense re-renders instead of the parents having to. That's one way of looking at it. I mean, the thing is, the child gets to choose what its data is, what its dependencies are, what it's fetching. It might be from a global store, and I'm going to get to this when I introduce the next primitive. I don't even view it as choice. It's more like the child just doesn't have to worry about it. They're kind of like, look, we're going to do my thing, and I'm just going to defer that the parent is going to handle the orchestration. Is going to worry about this. I mean, obviously with lazy, it's always nested, but the way we do this in Solid is instead of throwing promises, we need some other primitive way of attacking this. And the way that I'm going to do that is something that we have called create resource. So let's look at this. As I said, our trade-off so far is that we don't get to pause, so to speak. I mean, we do pause, but we don't get to like throw away the whole render. We actually want to keep the render. As I said, it's more efficient, but it means that you have to put in the null checks yourself. So what is create resource? Well, what did I do here? Yeah, don't worry about this. We'll just put the solve right in. Okay. Create resource is like a special signal that is driven by something reactive like a signal. Like if you don't include this as final, just fetch once. But for our example here, we're going to fetch on each number change. And then it calls a fetcher. And in our case, it's just an async function. It's basically something that returns a promise. You get the query. This is very much modeled after React query, very intentionally. I just like the kind of API. I mean, in this case, I needed to have explicit dependencies. And you might be asking, why, Ryan, would you bother with this? Well, can't this fetch function just be tracking? And the answer is, it could be, but then I can't separate the side effect, like the fetch, from the reactive part. And the reason I want to do that is I want to control it. And for SSR, I really want to control it because resources have a big part to play in server-side rendering, which we won't get into today. But essentially, for SSR, we handle this automatic serialization for you. And in that sense, resources are really powerful because we control when we fire that promise, we can actually basically start the fetching on the server and then have the client side go, okay, I'm fetching on the server. When the server finishes sending that data along the stream, resolve a promise. I basically replace the promise you would have done on the client side with basically a promise from the server. So by separating them, we can still track the ID. We can still create our dependencies so that it updates in the future, but we can basically use streaming to stream a promise from the server to the client. And that's a core part of what I wanted to do here. So that's part of why I went with this thing, because I needed to separate the dependencies from the fetching. And I mean, I could have used a dependency array or put at the end like React, but there's just something so nice about the kind of React query pattern of like, here's my query parameters and here's the fetch. I just copied it shamelessly. So with these resources, again, you notice there's no suspense in this example. And again, it's because resources don't require suspense. Internally, our lazy component actually uses resources. Resources are actually the way I trigger all of this. I just needed one primitive that knew how to handle promises and the concept of staleness, and then converted that into a signal. Once we convert it to the signal, we don't have to dirty the rest of our tree, so to speak. Like one of the problems or classic things with async functions, like async await, and is that they actually like, now everything's async and then everything is in await and then you're await, and it kind of permeates through the whole system, this concept of coloration. And in Solid, we're already using signals. So I was like, let's avoid the coloration. I don't want to like enter like now everything needs to be await. Signals are already our way of communicating, and they're free of components. They have all the qualities we want. So the problem with the async await, people are like, why can't you make an async component? I'm like, why would you want to? Because if you literally just stop rendering a component in the middle, first of all, we have some problems with the reactivity because await or like will continue without our ability to interject. I have no way of getting it back under a reactive context. A generator would like give me a way to intercept, but just a simple await continues, and then I have no chance of wrapping the context. But you're actually stopping things. Like, don't you want to show a fallback? Like I guess a parent could provide the fallback, but the granularity is wrong. You don't want to be pausing components, because then you pause the whole thing. If you paused a specific binding, maybe arguably that would work, but component level, it's too wide. And then I was like, why would I had this idea of putting like RX observables or promises into the data bindings directly, but then it's like you have to support all these other specific syntaxes to wire this stuff in. And the beautiful thing about signals, as you guys know, is you just write expressions like normal JavaScript. Like, sure, there's a function call in there, but essentially you just, in the templating, you don't have to worry about dependencies. You don't have to worry about piping and streams and async await, like generate, like you don't have to worry about this kind of stuff. If you just write like an expression like count +1 or like, you know, first name plus last name, whatever you need. And we already have all that. Why dirty it? Okay, question here. So wait, so create is watching that user ID and reruns the fetch function, right? So in SSR example, the first time it will run on the server, then in the future it will run on the client. Yes, essentially, the fetch function always runs, even on the server and the client. But when you're in SSR mode and you're doing streaming, and even actually in SSR mode and async, it's the same thing. It'll run the fetcher, and then when it goes, it'll run the like the user ID part. When it goes to do the fetching, instead of calling the fetcher, it'll go, oh, I've already got a value cached, or I already got a promise waiting. I'm going to use that instead. So for async rendering, when it's already completely serialized on the server, like, and we only send it at the end, it'll go, oh, I already got the value there. So it'll just like replace the fetcher with the value. But because it called the source part, it'll track it. So when the source changes again, the cache isn't there, and it'll have to fetch it, for real. And it's similar on the streaming side, except in the streaming side, if the server hasn't finished yet, we just pass it a promise based on the server finishing. So yeah, that's the best way I can kind of put it. Like we basically run it like normal, kind of sneak in a different promise. And then when that promise resolves with the server data, which obviously could start fetching way before, like if you had to wait to the browser for everything to load and then do the request to the browser, it's way slower. Instead, the server started that request the second it started rendering it on the server. It just comes in over the stream all over the initial request. I mean, that's why streaming is so powerful. You can't, it's the fastest on fast and slow networks. It basically is the best of all worlds. And that's why React is putting in React 18. Resource handles this all for you automatically. As long as your data and your resource is serializable, we just take care of it for you on the SSR side. And I will talk about SSR in the future sessions, definitely. Anyway, where I was heading with this. Yeah, so I've made create resource pretty useful on its own, right? We have like loading states and error handling messages, and basically like the data. I want to point out though, like JSON stringify luckily works on null, but like my point is, if you were doing something else here, like with user, like user.name, and you weren't guarding the loading state or guarding that they had the data there, this would fail, and you wouldn't really think much of it because you're not using suspense or whatever, and that's the behavior. With Solid, adding suspense doesn't change the behavior of your reactivity. It's still a signal, right? It just gives it a way of tracking. So the question is, how does suspense work with this, right? Because I made a basic example with suspense. Oh, guess what? It's like exactly the example that we did. I wrote these tutorials like half asleep. I forgot that I even did this. It is exactly this, the simulated delay. And then when we solve it, it's like literally the exercise we just did. That's kind of hilarious. Anyway, my point is, suspense is a context provider, right? I'm going full circle here. And create resource you internally uses use context to get a counter. In fact, you're gonna love this. It's not unlike the counter example. Actually, sorry, it wasn't in this. It was in the previous context. It's very similar to the counter example that we're using on the counter context. It's almost identical. Like there's a counter with an increment and a decrement method, and we just go, like it's that kind of mentality, right? I mean, we push the promises on the stack, and as they resolve, we keep track, of which promises are resolved or whatnot. But essentially, it's just a counter, and when all the promises are done, then we can, flip mode and switch it. It's a show statement with a counter in the simplest sense, and that's why it is so easy to implement suspense in pretty much any framework, whether you throw promises or do this. Like Preact has suspense, Vue has suspense. We all got suspense in this simple way. Sorry, question. No, Solid No, Solid doesn't use SSR by default. You need to actually do a setup to do it. You need like different compiled output, a whole different thing. I'm going to cover SSR in another thing. We have SSR just like any framework, React, Svelte, Vue. They all have SSR. I was just saying that I designed Create Resource as not just thinking about client-side rendering, but also anticipating the need for server-side rendering. So there were some questions that came out about how server-side rendering works. Create Resource, well, it's convenient to handle these nice loading states in the client, and Suspense is really nice. The real power is this lets us do async rendering on the server and streaming. And this is the exact same thing React 18 and React team's been working on the last 3 years. I implemented in Solid about a year ago. So we're a little bit ahead of the curve, but yeah, that's gonna be a topic for another stream, I think. But yes, we aren't server-side rendering by default. It just it informed my design here. Anyways, back to our context and our Suspense example. Where I was going here is, yeah, it's just a simple counter. When it's done, we show it. And the thing is, a lot of frameworks just added Suspense and called it a day, right? Actually, you know what? I missed one vitally important part about resources that I think we should talk about for a second in terms of Suspense. The reason that Suspense works is, I was talking about the counter, right? But that counter is not based on the fetch. Like, sure, lazy in this case is really obvious, like it's doing the fetch, but it's based on the read of the signal. It's not that the fetch happened, it's that the resource was read. In our case, greeting is being used right here beside it being fetched. So in the sense, we're reading greeting essentially, so it's there. But if I go back to my resources example here, and my point is, it would be this read that triggers Suspense. That is the key important part here. That's why there's context and boundaries. You can put the resource in a store. It can be used in 10 different places, but it's only going to suspend when it is read under that Suspense context. This is actually one of the most important parts of this. This is why the inversion works. It's not based on where the fetching happens. It's based on reading the signal. So as I was kind of getting to, I kind of got ahead of myself by talking about how like all these frameworks have Suspense, but I want to make sure that this fundamental point is understood. Like, if you have, like, I mean, yeah, let's just do it. I'm just gonna like spell it out here, right? Because you can nest Suspense too. People, and it's only the nearest Suspense that actually matters. Again, sound like something familiar? Yeah, context, right? Right? It's only the nearest Suspense. So this, it does give control. That's why when I was trying to talk about stuff, I was like, I was kind of hesitant to say about the children control. In itself, it's not completely that, but it's important to, oh, damn it, got ahead of myself. Suspense. It's important to recognize that it's just context. It has all those same characteristics, which are, funny enough, the same characteristics we want. Okay, so here's the thing. See, I got a Suspense boundary here in the same component as I'm loading the resource. Maybe I'll put it above so it's more visible here, but I think you guys probably saw my point. Hello, right? It's never switching because there's no resource under here that read it. Like, it doesn't care that there's a Suspense boundary here, because Suspense only listens for resource reads. It doesn't matter that other data is fetching. right? Whereas, we could replace this whole loading state stuff that I had here and just go, let's just do this. If you so wished. It's the same behavior. Because now suspense is triggering because it is being read underneath. So I think that's important. Sorry, reading the signal triggers the fetch. Yeah, I mean, the resource here is like whenever user ID signal updates, it calls fetch, which is fine. But it's actually reading the resource that triggers the suspense. If I hope that part makes sense. I was trying to show that if I just had a suspense component in here, it doesn't care if the resource is fetching. It only cares based on this. If we had some multiple resources going and they're fetching, back and forth, it's only the particular resources that are read by that specific suspense boundary that it's going to cause it to suspend. Yeah, that's what triggered. This is what triggers the counter I was talking about. Yeah. It's not user that triggers it, it's user ID. Sorry, it's similar. It's user ID triggers it, returns user. When we start, it's undefined, right? At the very beginning. Well, let's refresh, right? It's undefined at this point. And because it's undefined, it's null. Create resource doesn't actually even run. Falsy values to this cause it not to run. I copied SWR's, like Vercel's React query like library convention for this. But then once you start loading it, you initially have no data. So what happens is you click it triggers it, and that triggers it actually flickers the signal. We actually make sure to flicker the signal when, the promise state changes, so when it initially runs, it gets all the way through here. It stringifies the undefined, but it doesn't actually care because there's no stale promise. It doesn't actually care. This being null doesn't matter. It just kind of goes through, acts as normal. Suspense doesn't happen. Nothing fancy. It just basically renders nothing. If you look here, this div pre is actually here right now. And then when we update the signal, that flickers it, triggers the promise. So now when this expression reruns, it goes, oh, I'm stale. I'm under suspense. Use my context, flickers the fallback, which then goes, oh, my count is 1. Show the loading state, and pull this out of the DOM. And then when it's done, stick it into the DOM with the new value. That's essentially the process here. Yeah, but without the yes, this is kind of true, but without the SWR, without the actual stale revalidation. And one of the funniest things I've been finding when I've been kind of building it, it's like, oh, well, maybe I should add a SWR type level on top. That's not what you actually want with suspense. I was actually kind of getting confused because I was like, okay, how do these work together? Because all the SWR libraries are like, we support suspense. And I look and I'm like, okay, suspense is fine, but how do you do concurrent transitions? And it's like, no documentation. So I asked on Twitter, and I suspected I knew the answer, but the guys who wrote the libraries, like RTK Query, the Redux guy, and Tanner Wilson, Tanner Lindsay, React Query, they're just like, we like our pattern, and they didn't really answer my question. And I think the truth of the matter is, SWR doesn't really work with transitions. It's not actually the right pattern for it. And I was kind of going like, well, how are you guys going to approach this? Do you guys have a plan? Do you switch modes, let transitions do their thing? And there was no answer. And then Dan Abramoff himself answered and gave me exactly what I was looking for, because I think he could tell what I was asking. And he gave me a deep dive on their plans for caching and whatnot. And it's all in a Twitter thread from I guess a week or two ago off my profile, but super interesting conversation. And So like, I think that there is a cache involvement, and I want to refine how that works. And there is the API, but other than that, the SWR element itself, I don't think is actually something we're probably going to reproduce core, because I don't think it's actually the core behavior. I think that's like a caching behavior that an app might want, but it's not actually fundamental to how this works. Okay, when you say counter, you're referring to the suspense component as children communicating similar context. Yeah, sorry. This is what I was saying, that suspense is actually a provider, and it's actually almost our counter provider that I was using at the beginning of this session. That's why I started with context. It literally just counts the promises that are read underneath, registers them and increments and decrements. And when it's like, okay, all the promises are resolved, show it. So it's basically just an internalized counter, essentially, counter context. That's basically what suspense is. It just counts the promises with a show component. You can kind of picture it. Take the show, basically both examples that I showed to this point, put together is basically all basic suspenses. So that is kind of the core of like basic suspense that you find in the other frameworks, right? The read part is actually really, really important. Sometimes people come in and go, "Oh, can't I like, can't I, use a different means? Like, why do I have to use create resource?" And it's because whatever means you do has to convert into something that is read, because we don't care if something is fetching. We care if it's used. So, if it's not used, count as 0, we don't do anything. If, you might have multiple resources, so, and multiple suspense boundaries and nesting. We want to orchestrate this all in a consistent way. So let me see if I can get to the transition example, because I think, without going to transitions yet, I think this is actually sort of seeing this in practice, right? Because this is what most frameworks do. They're like, yay, we have suspense. So, I've got a very simple router here: switch, match, child, uno, dos, tres. And these childs are just, they're faking a sort of data load. I've got my content. This is our database, uno, dos, tres, our lookup table. And we just making a random promise for the delay timeout. And each child has a create resource where I'm not even using a first thing to drive it. It loads its data. And essentially, the promise doesn't even load the data. The promise just tells you what the delay was. So it just tells you how long it loaded, just for our sake. And then the content actually loads in right away. It actually has nothing to do with it, but just for our sake, for example here, basically this is the resource read here to know how long it took that our arbitrary delay worked. But essentially, that's why you say uno was loaded in 161 milliseconds. This time it's 578. This time it's 163. It's just a random number. And basically we switch to the new tab, and we show our loading state while this resource is loading. And when it finishes, we show the time and we show its content. This is basically the kind of core mechanism where you see people use suspense, right? And as I said, this create resource could have been in a store that you're using. It doesn't really matter where the fetch happens. It only matters that this page needs to listen to this particular time. And this is great. I mean, we already see great benefit with suspense, and it's a similar thing with error boundaries, which I haven't gone to, but it's the same idea. Basically, we use context, and then whenever an error happens with an execution, I just crawl up the context to find the closest error boundary context, and then to trigger its signal to enable its view. It's, again, just a show component, right? But more or less, this is the basic thing. But I mean, you could picture this loading being a bit nicer, maybe like a skeleton or something. But is this really the best UI experience you could be having here? Don't get me wrong, a lot of apps work like this. This is if there was multiple promises and resources going, if having a skeleton or something here is way nicer than having like a dozen different spinners coming in. So coordinating this is already such a big win. But can we do better? And I might not be able to get, well, let's see how far we get on in terms of the implementation mindset here. But the key to this is transitions. And transitions are really the powerhouse behind where, like, Suspense is fine in terms of like loading state, but transitions are much, much harder to do. And in fact, currently, there's a couple small frameworks like Free, which is another another VDOM library, maybe a couple odd outliers, but generally speaking, other than the one or two that you've probably never heard of, Solid and React are the only libraries that support transitions. Preact doesn't, Inferno doesn't, Vue doesn't. And in fact, they went on the record saying that, we don't think the fiber architecture or concurrent rendering is worth it, right? Our stuff happens fast enough. And here's the thing. They're kind of right. And as you guys know, Solid's pretty fast. So if they're saying they're fast enough, I'm sure Solid's fast enough. But why did I implement transitions? And it's this very demo. Something very similar to this. Like, I don't care about the time slicing stuff, and I can get into time slicing. We'll see. But the reason this is so freaking powerful is because of this. You guys got a feel for this transition in this feel. The thing is, this isn't the way the browser works. I mean, you might think it's the way the browser works, and if you take a long time, the browser does work like this. You see this flicker of white, you see this regression. But I work on MPA frameworks for streaming, and trust me, you don't see this happening. As long as there's content. The way the browser works, that's hilarious. It's like the styles suddenly kicked in. Okay, yeah. It's weird the styles weren't loading, I guess, initially. Okay. Browser works more like this. Notice there's no more loading state anymore. I click the next thing, and it still takes time, but there's no loading state. Well, that's not completely true. If we get one that's significantly longer, you saw that it kind of grays out like there. I don't know if you're catching over the stream, but essentially I gray out the text if it takes too long to load to give you some kind of indicator. But generally speaking, why fall back to a skeleton state like our loading when we already can show you what's already on the page? This is much nicer than most of the time. And this is the way the browser works. It'll keep on showing you the current page until the new page loads, as long as it doesn't take too long. That's why we don't see the white flickers that we've seen in the past. Now, don't get me wrong, Suspense is here. We load the page, see that? Loading. But when we transition, it's just all smooth. And this is this is the why. I saw this demo and I'm just like, okay, I need this. I mean, don't get me wrong, you can do this lots of ways, but it all involves the parent making the decisions, like going, okay, be aware of the loading state, and that's fine, and you can orchestrate at the router level and all this, but why do we love Suspense? That inversion of control, don't worry about it, If the child needs to load, let it do its load, and we'll just take care of it. I saw this, and as I said, this is a no-brainer. This improvement beats out any fancy transition animation you're going to put in. I was playing around some Hacker News demos recently, like doing some size comparisons and stuff, and I was doing one of the view ones, and I was like, oh man, like they really nicely do this like cool like thing when you switch between the different Hacker News pages and Svelte and all this, and I'm like, oh, that's great. But honestly, I give that all away to have this behavior because it feels natural, it's not distracting, and it just works. It just scales. And this is, as I said, what the browser does. It's really well thought out behavior. You can add some pending indicator. If you ever watch when you load something that takes a long time in the browser, maybe they put like a little strip along the top. And I have some demos probably somewhere that I can pull out. Actually, you know what? Let's look at the more Suspense tabs. This is our classic one here. This one is it's the same example, except I added a global loader in here. This is when Code Sandbox is like, did I crash Code Sandbox last time? Let's add more fuel to their fire. This always happens to me when I'm trying to do a demo with Code Sandbox. It just like, I do some bad stuff, I guess, with Code Sandbox. I like crash it. It's not going to load for me now, obviously. We'll let it do its thing and see if it ever comes back. But where I was getting at is you can use this pending state a different way. And how do you use transition? Well, you use transition or start transition, but this is the original. And basically, it gives you two methods back. It gives you a pending, which is just a signal to tell you like, hey, I'm doing some work, and start, which actually wraps the transaction. And that's the thing. Use transition is like a different time of batch. It's like an async batch. This is how we know what we care about for the transition. It's not everything. It's any downstream change that happens because of this change. So this way we can handle it in isolation. And this start transition, so it happens, sets a tab, and that sets this whole thing in motion because it changes which tab is selected, which changes, and then hits a resource. Now, if your transition never hits a resource read under a suspense boundary, no harm, no foul. It just continues on. But and it doesn't even matter if a resource runs. Again, it matters only if it would cause something to suspend. And once it causes something to suspend, the resource goes, okay, I can't just let this pass. I need to actually hold on to things. And this is where all the complexity comes in, right? Because while it's sitting there holding on to things, what happens if you click on the page, right? Come on, load. Really? Code Sandbox is just done for me today. This sometimes happens when I have like other windows and debuggers, like in a breakpoint, like sometimes, but like this is not what's happening. I closed everything before this. They literally just. All right. Well, thank you, Code Sandbox. Let's try a different demo. Or open it again. It's like these aren't real errors. No. Okay. This one. Okay, yeah, I just hit the Code Sandbox is just not happy. All right. Don't need you, Code Sandbox. Let's continue. But essentially, and this is hard to visualize, definitely, is we actually need to be able to update the reality in front of you. And Code Sandbox actually have a whole bunch of different Suspense demos, more than I have in here, which actually show that concurrent that those updates happening. And it's the idea is actually we fork reality when we start the transition, and if nothing else happens during that synchronous execution, we can just kind of replace it in and move on with our day. But if if it gets held like it does read a resource under a transition, then we actually have to stop execution in a sense. We finish doing all the computations and get to that point because technically speaking, our resources get handled during the computation phase, not during the effect phase, which makes sense because effects happen after render, and by after render, it's too late. But essentially, we don't run the effects. We're like, hey, stop! Don't run the effects, and don't merge reality back in. And so we actually have two realities going at the same time. And it's a little complicated, obviously, explained mechanically, but you can continue updating what's in front of you. And if it's under transition, it will continue applying only to that offshoot transition reality. But if it's not, we'll just apply the change to both realities. And the reason for that is that means it's whenever the other reality merges, it will have the combined changes of both realities so that it can just replace the reality that's there. And yeah, I mean, this is why concurrent rendering is kind of crazy. And React has a slightly different model. What they do is they have the same kind of render off screen of the VDOM, and then it's actually very similar in that sense. And then if there's a change, they just re-render that VDOM until they finally get the updated VDOM, and then they merge that back in. In Solid's case, we don't do diffing, so we just kind of hold our elements and apply granular changes off screen, essentially. So we actually, the trick to this whole thing is no existing effects will be rerun during that phase while it's hung, but any new render effects will run during that time. So we actually create the new DOM nodes that are going to be coming in, like in these tabs, but we hold all end user effects, and any existing render effects or end user effects related to that change will have also been held. So we actually, again, like I was talking before, create that future tree preemptively. And even though it's not pure in a sense, it's also not, the effects aren't something that are seen from the outside world. So if we actually canceled it, we could just throw it away. Sure, we created some extra DOM nodes and that's wasteful, but again, you're waiting, right? So if we're being optimistic here, what ends up happening is we actually did the DOM work ahead of time, and when the final stuff comes in, we're just inserting it. You do almost it's the same continuation pattern that we do with the normal suspense that we're doing with the concurrent suspense. It's just where you use the data that gets updated. If you had a bunch of stuff under that suspense boundary, you actually do that rendering up front. And how do we do this, right? Because as I said, React re-renders the whole tree every time. We can't do that. It's granular. And that's the crazy part. And there's probably no way that I'm going to be able to show you, but we actually fork the reactive nodes. The signals and the memos actually have alternate versions of themselves. And if that sounds like quantum physics, I've thought about naming it along those lines, because that's what we do. We have all these atoms, reactive atoms, and we create different versions of them to represent different realities, and then you get the reality you observe is I don't need to get more into quantum, but if there was a concept of quantum reactivity, I think this qualifies. Yeah, no, exactly. So, trying to go through the code here would be insane, I think, to kind of trace through. But I just wanted to understand high level what transitions are, and I'm gonna give a little bit more explanation. That's mechanically how transitions work. So you can actually think about it re-rendering that screen off, you know, re-rendering this view, the child off screen. In fact, rendering all of it, and it when the promise finishes, it only has to update this text here and insert the nodes that it already created. But this is, again, is why I view concurrent rendering as important because of this navigation thing. Because you can load the next page, do it in parallel without affecting what's in front of you. But it has nothing to do with time slicing and whatnot. Time slicing is the other part of the equation, and I think that it has value, but I didn't see it at first. And time slicing was actually something that was really hard for me to see, because if you have this perfect continuation like Solid does, you're not doing any extra work when you pause. Like, with React, if you pause and then you restart again, you got to do a whole bunch of extra work. So I was like, who cares? So but I was like, no, yeah, this is super true, and why I don't like SWR, like, as a pattern here, because before I get into time slicing, you guys can kind of see why transitions are better than SWR in a sense. Like, can you picture navigating, showing the old data, and then having the new data just slide right in? Like, that's the SWR pattern. And I've seen it on Twitter too, and it still jolts me to this day. Like, I prefer when they're like, "Oh, we have new feeds," but when you load something, I don't care how quick it is, showing me the old data and then showing me the new data, I find it disjointed. I would have rathered if you just held the old thing a bit longer. Like, I actually I went around my workplace, and I showed them this demo, and it was an older version, which did have the old behavior falling back to the loading screen eventually. But if you ask someone and show them this experience, maybe with a better pending indicator than this gray flash out, but of course, Code Sandbox is not being my friend today. I'm gonna give it one more shot. And you compare, like, this nice solved version with the reset version and ask them which one loads faster. Most people will tell you that that this is slower, and that this one actually loads faster. They'll be like, yeah, this one loads faster, clearly. And I was like, no, it's random. It's like this. It's the same. And SWR has the exact same problem with it. I don't care if you're showing, as long as you're like, it removes trust. You kind of go, am I seeing the old data? Like, the thing with transitions is, that if someone's going to show you the data, it's the up-to-date data, right? I mean, there's arguments for caching, but I don't think that should be the built default. I think the default should be like this. And then if you have a need to cache and stale, like, sure, fit your use case. But by default, this is a much nicer experience. So yeah, let's. I think that probably the last thing I'm going to do for the stream today is talk a bit about what do you call it? Time slicing, because I've actually added it to Solid in Solid 1.1 as an experimental feature, but it took me a while to get here, because I already had this idea of create deferred, which is a memo that uses prioritization. And the best way I can put this is, do I still have my set timeout example? Yeah, here's my set timeout example. Now this is a simple example here because we're just doing this and we're showing the fallback loading state. So people know that it's stale, but picture if, I mean, I'm going to go back into set interval mode. And I'm going to, oh, sorry, I'll put count in here, just why not? And here's the thing. This is a simple example. Actually, you know what? I don't think this example will scale the way I want it to. So I'm gonna switch examples here, and I'm gonna open something up in my VS Code environment. So give me 2 seconds while I load up a window for that. But what I'm trying to get at is if you had lots of those counters, enough that you would actually need to schedule changes, a simple timer could cause tearing. And by that I mean that uh, if you decided that you needed to stop work, essentially, like if you decided that it wasn't worth doing, like basically you were doing too much work, more than you could fit within a render frame, you suddenly have this issue where you could be showing an inconsistent state. You could be showing like some numbers, like pretend to add a dozen of these counters or whatever. You could be showing some numbers that are at 1 and other ones that are at 2. And the perfect example for this is the Sierpinski's triangle demo. Let me see if I can open that in a browser here to show this one. Okay, let me get it in Finder and then see if I can get this. Yeah, okay. I'm gonna copy the URL. You guys might have seen this demo before. Seen this one? See lots of 1s and 2s and 3s, right? And I'm pausing it for a second, kind of looking over here, but okay. So we have all these numbers changing. Now, the browser can handle rendering this. This is not a hard amount of work to update a whole bunch of triangles. Some people made this demo and were like, look, I can make 10,000 circles and whatever, and it's faster than React. That was never the point. The real point here has everything to do with what end user computation work. Like what happens if you how should I put it? If you're running arbitrary code in your components that's actually expensive. And I'm going to show you exactly what I'm talking about here. Okay, what am I looking for? Okay, so I'm going to switch which screen I am showing right now, and we're going to look at the Sierpinski triangles code here. Okay. So it might be just easier to share my whole screen because I want to go back and forth between this. Okay, so this is the Sierpinski triangle example, and I'm just going to run pm run build and make sure that we're all up to date, and then refresh. And here is our demo. There's nothing special about this. Solid could render this, easily without even trying. Now, the sake of this example is what if we had something expensive? Can you guys hopefully can see my VS Code here, but I'm going to make an expensive memo that has a timer in it. And here's the thing. I think after I show you this, you're not only going to get why you're just, I think you're going to understand why React does it, not just why I found this may be considerable in Solid, but let's look what happens. I mean, this is, if you should be seeing it step, because now we put this delay, and every time the number changes, we do this. It's actually exponential because each parent and child do this. I put this literally in the triangle code. If you want to understand the layout of this app, the triangle demo app is it draws a triangle, and each triangle draws 3 more triangles unless it gets to the target point where it draws the dots. So essentially, this memo that gets passed to the child is compounding. So maybe the top node has this delay, and then it basically passes that delay on and on and on. And in the case of React, it's the component render cost. But in the case of Solid, where we flatten things, so it's only the final dot that's actually doing the work. Like it's only the final text here that's doing the actual work. We're still compounding it because each stage added that expense. So by the time you get to the bottom, you've compounded all the parents. So sure, Solid in this case isn't re-rendering all the components in between, but we still take the exact same cost at the leaf nodes. So you can see that this is just horrid. So my first thinking of solving this was adding something Solid called create deferred, and I actually copied portions of the React scheduler, and I was like, okay, well, let's just do this. Yay, create deferred. And create deferred completely, I have to build it first, right? Sorry, guys. Create deferred actually solves the problem. Ta-da, works beautifully. Now, I was fine with this, and I was like, screw time slicing. No one needs time slicing. And in fact, create deferred is really powerful in that if this was something that the system couldn't render, like something 3D or expensive, we're actually granularly breaking up the work, because by using create deferred, it's using request idle callback, or a version of it, essentially, like a more optimized version that React came up with. But it's also, how should I put it? It's because it's Solid, we're just doing that same pause and resume. So if one dot gets the chance to run, then it updates. And if another one doesn't, they can all independently update, right? We don't need React Fiber because our stuff's already fine-grained. So, and it's end-to-end, right? If you're doing some kind of timeout and based on like a queue, you basically get each separate computation runs all the way down to that final effect. So each one can update independently as you have time. And obviously my computer is fast enough, you're not seeing this, but this actually waves out. Like if it runs out of time in its schedule, it actually kind of flushes out like a wave. But here's the problem. At any given snapshot, this can be inconsistent. Do you know what I mean? Because we're opting into that inconsistency, but the top half of the triangle might be at 2 and the bottom half might be at 3. And I don't mean, like, obviously you can reproduce that with a breakpoint. I mean, you can interrupt the synchronous render, obviously. But I mean, from like an asynchronous standpoint, you could actually say like the settled state that others can observe can be glitched. And as I said, if something's so expensive that the renderer can't handle it, like some 3D or something, you have to do this. Like there's no other way. Like you can't defeat the physics of it all, if that makes sense, right? Because like what can you possibly do? Because no amount of scheduling is going to save you from the work you have to get done. But in our example here, it wasn't the rendering that was expensive, it was the calculation. So React was like, well, I want to do this, but I actually only want to present the consistent view. And that's actually trickier to do because when you kind of think about it, like you have to be able to interrupt, or like being able to stop, pause, like I was talking about before. But you also can't apply the effects until you get to a point where everything's settled. We already have a mechanism that is based on only running the effects when everything's settled, right? Transitions, right? So I was like, okay, fine. Let's do this. So I I did add start transition, and because I think because it's kind of I'm big, you guys know, on code splitting, right? And the thing is, start transition or use transition, I want built into all the design systems, into every router. If the end user never uses Suspense, we can code split um, the whole thing out. Like, okay, like how should I explain it? If you never use Suspense or transitions, we don't need any of that code. And Solids, the way it's built for tree shaking, can actually remove all that code. And you might be asking, like, how the hell can you do that? Rollup and ESBuild and a few of them are so freaking smart that based on constants, they can actually rewrite your code. They can actually go, oh, that branch can never be hit. And in so our transition code, our concurrent rendering code, can be actually peeled completely out of the core. Like if you just don't use these features, your compiled code has the concurrent rendering pulled right out. Like it's like, I mean, there's a few extra checks because there's a few places where it's like not smart enough to do the if statement, but generally speaking, the whole thing just gets ripped right out. And but the problem was I actually want people to use transitions, in their libraries, just because it should be hidden. The end users shouldn't be the ones thinking about the transitions. The router should have it baked in, and Solid's router actually does have it baked in. But what if you never use Suspense? We never want to have concurrent transition code. And so, again, Solid's smart enough that if it goes, okay, you never imported Suspense or never used Suspense anywhere, we can still rip that transition code right out of the core, and your bundle will be smaller. You won't actually have it, even though the code for transitions is right in the most core part of the reactive runtime, right in the core like running thing. That code just gets dead code eliminated. But what if you use Suspense and transitions? I didn't want to add the scheduler. The scheduler is the biggest chunk of code. You know how Solid's like 6.3 KB? Most of the time, you're not actually, Solid's real size is like, it's smaller than that. It's smaller than Preact generally. The scheduler is actually one of the biggest chunks of code. So again, this is why there's this enable scheduling, because using that same kind of code thing, if you never call enable scheduling or pull in create deferred here, if you never use either of those, the scheduler never comes in. So even if you're using transitions and Suspense, we don't have to pull in the giant scheduler unless you want to use the scheduler. And as I said, I don't know if it's worth it, but I was like, let's do this, right? So what if we, I'm not using the use transition here. Start transition is just the shortcut for doing that. But what if we just said on every interval, wrap this set the seconds, which is setting that number in as transition, right? And let's just change this back to create memo, just some work that gets done, right? And now we use start transition and we enabled scheduling. And a minute ago, this was choking, right? But now we get that same smooth thing. And this is, in a sense, maybe better than create deferred because there's no tearing. There's no potential tearing. you might be thinking, well, if this is just a fancy debounce, wouldn't you ever get stuck where it never updates if it's slow enough? That's true, and that's true of React. React, they might have there's a hard limit there somewhere, but basically, if you just keep on piling in on the transition, React 2 can't actually handle it. Like it it essentially is just kind of debouncing. So there are still limits, but why is this so powerful? Well, look at what I did. This is just some normal code, and you're just running it, and somewhere up at the top, where that change happens, the transition is. So sure, I knew that this was slow, and I optimized it with create deferred. Maybe I could do some work. And the truth of the matter is, I kind of knew it's slow because I already put in a create memo. Do you know what I mean? Like, and that's a key difference between Solid and React. You kind of already know the points that are slow, so maybe you can just optimize at those points, like using create deferred or making the decision. But what's cool about transitions and using the scheduling slices, somewhere at the top, you just put start transition, and then it just magically fixes all your expensive stuff. Like if something's too expensive, it just fixes. And I think this is what they were trying to solve at Facebook. They were essentially like, I don't know what Facebook developers are doing. They they might be doing something really stupidly expensive. Now, if I just tell everyone to use transitions, I can just fix all the end user code. If you're doing something stupid, your app still behaves properly, right? You don't actually need to go in there and optimize or death by a thousand cuts. It just works. It's kind of attractive, right? Like I know I work for eBay too. You big company, not everyone has the same experience level. You got legacy code, bam, suddenly you have the magic solution that it doesn't fix the performance problems, but you make sure that things are never terrible, right? And I think that is super. I think that's super powerful. I'm not sure whether we need it because I said one caveat with our approach here is that essentially, and it's worth kind of calling out, is that we can only optimize the create memo stuff essentially because just a second, sorry. Solid doesn't rerun components, and if you pull that stuff into effects, it's too late. Like if you just rendered that slow computation inside of I'll close this for a second. If you just rendered that slow computation inside of something in the render tree, like you just hoisted it and didn't wrap it in a create memo, it's happening too late in the render cycle. So we do need it to be in a create memo, which means you kind of have to already identify that it could possibly be expensive. So that kind of removes, I guess, some of the benefit, but it's also just coding standards with Solid. That's when you use create memo, so that makes sense. But you can kind of see that if your app scales to a certain level, like this is a really easy automatic way of doing it. As I said, that the fact that we already know what's expensive kind of makes me less on board of whether we need it, but it's a cool tool to have. And I wanted to clearly show you the difference between time slicing and concurrent rendering. Even though you use concurrent rendering to do time slicing, the real value is actually the navigation story, like the tab story that I'd been showing along this whole time period. And Code Sandbox is just not going to play ball. That's so annoying. Because I had some really good examples I wanted to show you guys. That's fine. Yeah, I'm sorry that I had to share my screen differently, so I haven't been looking at the questions. Let me do a quick catch up and see where people are at. Yeah. I mean, to be fair, the challenge, if you picture the way React scales and the way the re-renders happen and whatnot, this mechanism makes a ton of sense, right? Because they can't continue as easily as we can, right? They don't have that same ability to just, you know, kind of pick up where they left off. And, the larger your app gets, the more compounded that feels. But also, when you work on a giant app, isn't it cool to have just like an instant way to make sure that no developer causes the whole page to snag to a fault? Yep, fancy debounds. Yeah, it's interesting though. But the one thing that I'm going to give the React team some credit here, and I think it's important that we do. I wouldn't have explored some of this stuff if it wasn't for them. As I said, I work for eBay. Our problems are slightly different problems. So, we're exploring different areas. React has seen the extent of what a large single page app is. Even if I've been working in single page apps for a decade, um, it was enough to like, and medium sized, large, like large enough that you really have to think about maintenance and stuff. It's not at the scale of something like Facebook, right? Where your performance issues considerations are systematic. Dom Ganaway, the creator of Inferno, he worked on the React team for a while. And if you everyone's like, oh, don't they use Inferno at Facebook? And they actually do in some places, but essentially they're doing tests. They're like, well, what if we just replaced React with Inferno or something like Inferno? Inferno's way faster. It didn't do enough. Part of it might be the way that the code had been written. Dom went on to make stuff even more performant than Inferno. I talked to him a bit, and I have no doubt in my mind that he made stuff in the same ballpark of performance as Solid. He just never released it using the VDOM, and that's why when that block DOM thing came out, and those kind of things, I was so big on promoting it, because that's not the bottleneck, right? There's fast libraries and slow libraries. Don't get hooked up on the whole VDOM thing. But execution model consideration, UX, like there are challenges to just pull that performant library in, breaking changes that would have been required for React. And I think they realized that the raw performance, the stuff that you get from like Solid or Inferno, Svelte, isn't enough to address their problem, which is slow, systematic end user code. And someone, being a little bit cavalier or whatever, might be like, well, why aren't you guys using reactivity? That would have kind of solved it. And maybe, but like, this is just a different scale. Like, as I said, Dom actually said when he put Inferno in place and they ran the tests, it wasn't faster across the board than React. React's might not be beating people in the JS framework benchmark, but in other, winning on raw performance, but in other more complicated UI scenarios, they actually perform quite well. Like they built it to fit Facebook. So, someone in a small app can go like, haha, you're so big, you're so slow, but it's not really comparable. And I think this is something for people to really understand, even about solutions like React Server Components. Those are for Facebook. They're actually trying to bring Marco-like features into React, essentially. For e-commerce like eBay, we needed that stuff from day one. That was like a non-starter. But Facebook was still PHP back in those days, and they had a good PHP solution. They switched to React, and then it's like, oh, there are trade-offs here. But to understand is, Facebook's not a e-commerce site, so they don't need the fastest loading time. React Server Components aren't for the fastest loading time. They're for better separation, almost like microservices you can think of. They're for, reducing after the fact client loading. Like, there's a lot of there's a lot of considerations when you have an app as big as Facebook, and like people are going, oh, like here's the solution for e-commerce, here's RSCs or whatnot. That's not really it. Like, I mean, it's nice. I think the real benefit is the API thing. I think Next.js should be excited about RSCs because now you don't need GraphQL. Essentially, you can get per component level API stuff built right into your tree, and you don't have to worry about this kind of stuff. But it's not the same thing, and I think you have to look at the use case for Facebook. I bet you for Facebook's use case, React is a lot more performant than everyone thinks it is. And because the people working on that team are brilliant and they are pushing the boundaries. And I think when people kind of jeer at it, it's an unfair assumption in terms of where things are at. So yeah, it's a long-winded explanation, but I have a lot of respect for the work being done there, and I see some of the benefit. Obviously, I get to enjoy the fact that something like Solid has such incredible raw performance, and that will probably be useful for any of your startups, small, mid-size, even mid-large size. But as I said, we have no clue how like Svelte would work at Facebook scale. Twitter's web client is a good show of React work. Yeah, yeah. I think Twitter is a good show of what the average desired React thing is, because Twitter's in some ways it's not as complicated as Facebook is. There's less stuff, and I think that's the target range in which of a single page app is actually the best, and I think React is a good fit for that size. And if your startup is trying to be something like Twitter, that's like it's a good choice. And actually my previous startup was about that sort of size. It was like a private social media, Twitter, Instagram kind of thing, and I built Solid for that task. I think Solid is actually ideal for like the Twitter use case. It's scaled to be, it's a little bit bigger than Svelte in terms of its target range of where it wants to be used. That's why there's a lot more consideration given to scaling. But that's its sweet spot. As I said, I think React sweet spot is actually a little bit bigger. It might be Facebook. Then again, maybe that's only when you get to React server components and all the future stuff that we haven't got to see yet. This was a question. I'm not actually sure what you meant by this. Relay was, I feel like RSCs were actually inspired a bit by Relay, mostly that GraphQL and Relay are super powerful and it actually solves the problem. And when I saw RSCs, I was like, don't we already have GraphQL to solve this? Like that was my thinking, because I was like, you can parallelize fetching, you can inverse the control, like Relay's pattern of using fragments and having the pages, like the whole approach that React's been doing here has been like looking at, like, let the child say what its needs and dependencies are. This inversion you see in Suspense, this inversion you see in Relay is allowing, if you want teams to move fast, you need to give them autonomy. And you don't really want micro front ends. I'm sorry. Like it's kind of like web components. Like that interrupt has a real cost, and especially for server-side rendering, most micro front-end solutions are not good for server-side rendering. Like they're designed to like replace stuff in the client, which is fine in some cases. But if you need to, consider performance holistically, there's more to that. And if you've got a big React, ecosystem, I'm sure they have other ways to split code, and as the server components probably help a bit with this too. Like you need these things to work independently, and as I said, Relay and GraphQL is one way. I think React Server Components is another way and it's very attractive, I said, for stuff like Next, because then you don't like Gatsby built GraphQL right in, and I think that was a smart move because it kind of removed that complexity. But with React Server Components, that kind of load function mentality goes away. Like even Solid, we have that load function, and I've been doing stuff that I realize now is similar to Blitz. Again, I've never looked at Blitz, but apparently we came to the same conclusion. RSCs is like a way of systematically solving the same problem in a really kind of generic way. We can't do React Server Components in Solid exactly because we can't diff. But I also arguably say that we can achieve the same thing a different way. And that's really where my quote unquote partial hydration exploration is going to go in the future. But I think that this is essentially the where things are heading in terms of this. I'm actually not sure if GraphQL, like I think there's enough. It's funny. It's on the big React Server Components are beneficial on the smallest setups and the largest setups, and I find this very often the case, and this is going to be a bit of me tirading on kind of one of my thoughts on kind of scalability. But often when you're in the course of scaling something, the best solution for the smallest case is also the best solution for the largest case, but it's not the best solution for the middle case. And this is why, like when startups and people try to copy the larger case before they're ready, it's the wrong thing. And it's unfortunately you had to go through this whole progression to get there, because React Server Components are going to be amazing for a small app or whatever, because you won't need an API. You'll just kind of like build your app and then go, oh, here's some server components and I'll load my data, and it'll feel like Rails all over again. It'll just be easy, right? Get a nice ORM in there, you're done. But once you get to the next step and you're like, oh crap, I have a mobile app. Now I need to export that API, and I'm going to be using it anyways. And then I want to be specific. I'm going to create GraphQL like that. It's funny. I worked for a startup and we built our own ORM, and I was kind of joking. We created something very much like GraphQL back in 2013. That's how I learned about ASTs and stuff. I basically made a universal query language based on Mongo's query language that could query SQL databases and Mongo databases at the same time. And then you could serialize that into a query string, and then the backend could convert that back into JSON, which we use the dot notation, which is how you do nested models in Mongo, to do relationship models in SQL as well. And that was like my big work, making these being able to deep query SQL through dot notation and relationship schemas. So yeah, basically trying to solve the same problem with GraphQL back in 2013 at the startup I was at. And what I'm getting at is like, this is a real problem, and you want, and when you're supporting multiple front ends, you want the ability to kind of extract that API and make it reusable. The problem is when you get to the next scale, like when you get past that and you get to like Facebook level, is yeah, sure, you have lots of APIs, and you have to consider governance of all those pieces. But it gets crazier than that, because you also have multiple teams trying to build this giant front end. So it's no longer as simple as abstracting to the API. It's almost impossible for the API to kind of fit your needs. And Relay is a really smart approach to doing that. But you have so many different considerations on data sources and governance and like inter-team things, that going back to almost that simple model, but like React Server Components, but doing it at a like larger scale, where you, instead of having one, one kind of app, you have multiple. It's easier to scale the smaller solution than scale the mid-range solution. And I often, as I said, this happens a lot. I often kind of credit this also to might as well just do this. I often also credit this to things like component refactoring. Like if you have, how should I put it, like you start with a single component, then you get more requirements, and then you make that component more complicated to fit your requirements, and then you maybe use it in new places and you add more features and it gets more and more complicated. At a certain point, the right solution is to break that component into multiple components. And you don't want to do that prematurely because you might break it up wrong. But if what you'll often find is that when you get to the end and you do break it up, you end up with a component very similar to the original component you started with. So you almost go through this dance where you started with a simple component, did a whole bunch of crap to it, and then have to undo that crap to get to a certain degree to get it to where it needs to be to scale. And as I said, my experience with startups and with, the way scaling other things is this pattern happens over and over again. So you might be thinking, well, why ever do the middle step? Well, the truth of the matter is, if you never get to that larger step, the complexity of breaking it up isn't worth it. Those boundaries give you so much extra cost and extra management. So I've also seen companies try and go from 1 to 3, and they're wrong. So I don't know if there's a good answer there. Sorry, this is weird because I'm talking both about code refactoring and large scale scaling. So take it for what it is. I don't know if I have anything more to share specifically about Suspense right now and time slicing, because my code sandbox examples are apparently never going to load. I'm going to try one last thing and see if this is just like some weird video card type thing where it's just being really dumb because I was trying to do it full screen on a different window. But because it's getting stuck on transpiling, I do not think that is the case. Yeah, no, Code Sandbox is just ruining my fun today. Now is probably a good time for anyone to ask any last questions or whatnot. Otherwise, I'm probably going to end the stream pretty close here. I know there's at least a few of you here, which is good. It always helps. Some guys know I used to play in a punk rock band for years, kind of pop punk band, and it didn't matter how big you got or what how good your typical draws were, especially in your area. Sometimes when you're like in large urban areas and you end up playing a little bit more on the outskirts or stuff, you always end up at that show where there's only a couple people in the audience, and you have this challenge where you you got to rock out as hard as you can, because it's just lame for everyone if you don't. But the funny thing is, like, it's kind of like dancing by yourself. You kind of feel naked, almost like embarrassed. But if you don't do it, you aren't doing the service, so to speak. And I think that was but it's so much easier when it doesn't matter how big the audience is, people are into it. And I think for some reason live streaming made me think of that, because I played hundreds of shows in the past when my band toured across most of Canada a couple times. Anyways, any thoughts using Solid Mutation Observer? Yeah, I mean, it depends on what you want to do. I actually had some fun here because early days in Solid, before I had the lifecycle for connected, disconnected, for like create effect to run after it connected to the DOM. I used to just tell people, like, do a set timeout. Like if you want to do an on mount, just before I added that scheduling, because create effect used to run, all rendering was create effect, and it all ran synchronously, and there's no scheduling installed, a year and a half, 2 years ago. And I'd just like you call set timeout. And for some reason that bugged people. I used this for years with Knockout and never had any qualms, but people are like, it felt dirty. So I actually came up, and again, I have a code sandbox for it that won't load, but I use Mutation Observer as a way of observing DOM. I basically added a faux event, and JSX had no problem handling it. Obviously, I probably wasn't using TypeScript back then. I mean, Solid supported TypeScript, but you notice that I almost never use it in my demos because it slows me down. But essentially, mutation observers can have their usage. I played with them for animations and stuff in the past, or like doing. The problem is mutation observers are always going to be like outside of the framework. So while they're good for simple things, you're probably better to use the reactive system. Okay, more specific. Mutation error with content editable. I don't have a ton of experience with this. I'd love to. This is one of those things when I was working at the social company that I was like, it would be cool if we could have the tags in the text like Facebook does, but we never actually implemented that. I never got around to that. Our tags are always explicit text fields, so I didn't get to actually play with content editable. I think there's a place for it, mostly because, as you know, with content editable, where the state lives is tricky. Like, if I've seen people make um, good abstractions over it where they can actually make it state driven, but content editable is almost asking for the state to be in the DOM, and it definitely takes some work to come up with the right abstractions. As I said, I haven't done this one myself. As I said, I worked on a lot of like paginated lists and infinite scrolling and like layouts like masonry and what is it called, justified grids and stuff like that. But I actually haven't played that much with content editable, so I think it's reasonable. One of the cool things about Solid is how low level the abstraction is. So if that's the best approach you would use with vanilla DOM, it's probably the best approach to use with Solid. There's no issue with that. But yeah, without getting more specific example or whatnot, and I'm not sure I'd even be able to help you with a more specific example, to be fair, just because I don't have a ton of experience with content editable. Anything else? Let me see here. I think that mostly does it for today. If there's no other questions, got me for a minute or two longer. I finished my drink here already. Okay. Kind of wind this down here, but if there's nothing else, can probably call this a stream. Longer than I expected today, almost 3 hours, but heavy topics, and we haven't even touched like server-side rendering, how that all plays into the equation. So, I look forward to continuing to do this, if people are interested. So, yeah, okay, awesome. What do we got here? Future conversation. I'm thinking about render for prose mirror, code mirror. Sorry, what do you mean by new renderer specifically? Oh, I see. That's what you're asking about, content editable. Yeah, okay. Yeah. That makes sense. Gotcha. Yeah. Yeah, that'd be cool. I definitely want to check that out. For a second, I thought you were talking about the universal rendering things, and that's something I've been kind of going back at a bit now, because I've been working on Solid Start, and it's hard sometimes. Like, there's so many pieces that need to come together for that, so that I work in an area and then I kind of go, okay, I need to breather and kind of look somewhere else. And I've been looking at the universal render again, maybe not applicable to this, but people want to do 3D rendering or canvas rendering, and I think there's some good patterns we can put in place to kind of generalize it, so that I can make a compiled output that would be more friendly. It's just kind of interesting. I was looking at the React solution, and they basically give you a way to intercept all the diffing thing, and I'm thinking, is that the right abstraction? Should we be thinking of it like a DOM? Obviously, with a virtual DOM, you have to think of it like a DOM, but with reactivity, everything's a side effect. I don't care what you do, so it might be sufficient just to do some of the optimizations that I do in Solid, in terms of like grouping effects or attributes, and some simple diffing. If I just add that in, creating a custom renderer for Solid might be all of implementing like 5 or 6 functions, like really, really easy. And we're not even going to try and reconcile it like the DOM. Like, why are we trying to insert the trees or whatever? Like, screw it. Like, if you return an array, it's an array. Like, we don't need to synchronize some kind of DOM or whatever. We can already use for to sort it, if that matters. We'll just give you power to control the insert, and you can do whatever you want with it. I don't know if we actually need to have diffing level things where you implement like what append before is from append after. I'm not sure. I think we're gonna have to talk to more people about how they want to handle custom renderers. But I'm thinking like if you're doing something like 3GS or Canvas or something in a terminal, like why are we like diffing array positions? Like it depends on the underlying technology, and I don't know if that assumption is the right one, or mobile even for that matter. I think I'm gonna need when I work on this, I'm gonna need to get some input, because right now the way I'm looking at it is the universal rendering could probably be something that I could make the compiler for in a few hours, and then it was just like, here, implement these 5 functions or something. So that seems too simple. I must be missing something. So, sorry, I know that isn't what you were talking about, but you just reminded me of the whole custom renderer thing. Who knows? Maybe there'll be a solid canvas thing that's like Flutter, and maybe that'll be cool. Okay. I've been rambling here a bit just to see if there's any more questions that comes in. Doesn't look like there will be, so I'm gonna call it a night, and I hope you all enjoyed the stream, and I intend to keep on doing this. It was fun, so until next time, see you all.